which babies first crawl based on a survey of 12 mothers conducted by Essential Baby. Construct a 95% confidence interval for the mean age at which a baby first crawls. Use the normal probability plots and box plot to assist in verifying the model requirements. Okay, so this is number 38 in section 9.2. Okay. So do you see that we have some sort of population that we don't know, where we don't know the mean and we don't know the standard deviation? But we do know a sample. Enough information was given to us about a sample, so we can find the sample mean and sample standard deviations and use that as our best guess. Okay, so we don't know this and we don't know that, but we have samples. Sample of size n equals 12. Right? They gave us 12 values. So we need to find the mean and standard deviation of our sample. Right? So one sample given is this. Okay. Here is our sample. So let's put it all onto list 1 and find the sample mean and sample standard deviation. So the only way this works is if the sample size is big, more than 30, or if it's less than 30, we have to make sure that's normal. Right? Otherwise, this doesn't work.
So then we have to graph it and see if it's linear because that means it's normal.
Correct. So if we do a normal probability plot, if that plot is approximately linear, just we eyeball it, then we know that it comes from a normal distribution. And while you're at it, you also have to create a normal probability plot so we can verify if these values come from an approximately normal distribution. That was the last thing you did in chapter 7. So it's really easy. You just have to put the values onto list 1 and then you do a plot, a normal probability plot. If you don't remember how to do that, let me know. I can show you. And we're looking to make sure that those points are approximately linear in our graph, and that will be enough evidence that this sample comes from an approximately normal distribution. Construct a 95% confidence interval. So what's the next thing we need to do?
So then we need to go over to the t-distribution.
Yes. A 95% confidence interval for mu. The formula is going to be x bar plus or minus t sub alpha over 2 s over the square root of n. Okay? So this is the formula that's in that you'll be given. It's in the back of the book. This is the formula for confidence intervals of mu. So it's centered at the sample the sample mean, right? Because we're saying that that's our very best guess for the population mean. And then this is our very best guess for the standard deviation of that distribution, which comes as S divided by the square root of n. And then this guy. And this guy tells you how many multiples of the standard deviation above and below the center that you have to go in order to trap the middle, say 95%. Good? Alright, so maybe off to the side, this is sort of optional. I like to do it, but you don't have to. I won't require this. T distribution. Right, we want to put in here 95%, and then that means that this is 2.5%, and that means that this is 2.5%. So that means that this value right there is T sub 0.025, which we already found to be 2 point something, right? 5.8 something.
Why is it automatically 0.025? Because you're dividing by half. So it's half of 2.5, right?
Right, so it was this one, 2.5708. Oh, sorry, 5606. 5706. Yes. Right, so the alpha is 5 when we're chopping it in half, so therefore this area must be 2.5. The t value that gives you that is this, and so this was t inverse. We did that before.
But that's wrong because the degrees of freedom is different.
Thank you. Okay, yeah, good point. So the degrees of freedom is actually degrees of freedom equals to 11. So it doesn't just depend on the area anymore. It's the area, but it's also the t distribution itself changes just a little bit based on the degrees of freedom. So this is a t distribution with degrees of freedom equal to 11. It's not going to be quite that number there. It's not going to be the number that we got before. So it's going to be t.
Still do in
In t 0.975 comma 11. All right. What do we get in that case? There we go. 2.201. Okay, and because of symmetry, I already know that this has got to be negative 2.201. Okay, so the values between negative 2.01 and positive 2.201 are the two numbers, the two t values that trap the middle 95% on a t distribution with degrees of freedom equal to 11.
So that is the confidence interval.
No. This is just how many multiples of the standard deviation above and below the mean I have to go to trap the...
That's T alpha.
Yeah, that's just this guy right here.
Yeah. And then you do the rest of it.
So this is telling me that in t distributions with degrees of freedom equal to 11, if I go 2.2 times the standard deviation away from the mean, below and above it, I will find the middle 95% of my data. Okay, well, I don't have a t distribution centered at 0. I have one centered at this number. And the standard deviation is not 1. The standard deviation is this. So I have to go 2.2 times this in above and below this number in order to find my confidence interval.
So let me just plug it all into that formula.
That's right. 38.25 plus or minus 2.201 times this, which was 10.001136 divided by the square root of 12, right? This is the standard deviation of the distribution I'm looking for. This is the center of that distribution, and this is how many multiples of the sigma I have to go above and below it in order to trap the middle 95% of the distribution. Okay, so now we can find that, and remember this part is called the margin of error, just this part that you add and subtract. So let's see, 12 to the 0.5 power. Don't you hate when you type in a bunch of stuff and realize your calculator's off?
No.
You're supposed to do that? I like fly by, I'm already halfway through typing stuff in when I look up and I realize the calculator's off. 38.25 plus or minus 6.3545, and this is what we call the margin of error.
So why is the margin of error just outside the mean that you come up with?
Well, it's the amount that you add and subtract from the center is what we call the margin. So it's always the fact that the mean is right in the middle of our interval, and this is the part that you add and subtract from it. Okay, so what we have is a t distribution. Here it is. It's going to come up like that. With degrees of freedom equal to 11. And we're going to center it at mu equal to 38.25. And we're going to say that, in a standard deviation sigma equal to this thing. Let's see what that is. It's 12 to the 0.5 power. 10.001136 divided by that answer. The standard deviation is just 2.8871, which is this part right here, the s divided by the square root of n. So this is my t distribution, this is my standard deviation. These are guesses, right? These are guesses based on my sample. I'm guessing that this is pretty close to the real answer if I had known the real answer of mu and the real answer of sigma.
Wait.
And now I want the middle 95% of this data. Yeah, you have a question? So I know from over here that in a t distribution with degrees of freedom of 11, in order to trap the middle 95% of the data, I have to go 2.201 multiples away from the mean. So that tells me I got to go 2.8871, 2.8871, and another 0.2. So this distance here, below it and above it. So this number right here and this number right here will trap the middle 95% of the data, where this distance right here is a multiplication of this times 2.201. So it's 2.201 times sigma, right? That's that. And so is this distance over here. It's going to be 2.201 times sigma is going to be that distance above and below the standard deviation. And that will guarantee that it'll trap the middle 95% of the data. And so to get it, I have to add that amount. So this amount right in here is this number, 6.3545. It's the multiplication of 2.201 times the standard deviation of this distribution.
So all you did to find the standard deviation from that equation before was divided by 2? That's what you just immediately wrote in the standard deviation. So from there above.
Oh, I got it from here.
Found the margin of error.
This is that. I'll put it in here. This is equal to 10.001136 divided by square root of 12. Right? That's where that guy came from. And so now this guy is equal to 6.3545. This distance above the mean is this, and so is this distance below the mean. I want to go 6.35 above the mean, 6.35 below the mean, and that'll be the two values that trap the middle 95% of my distribution. Okay, so let's figure out what they are.
So it would be negative.
Say that last part again.
6.3545.
1 second, let me figure out these numbers and then I'll repeat myself. 6.3545. Okay, so the interval that I'm getting, so a 95% confidence interval for mu is going to be equal to 31.8955. That's this guy right here. 31.8955 is this value right in there, the lower part of my interval. And the upper part of my interval is going to come from adding this plus that, 38.25 plus 6.3545. So I get 44.6045. Okay, and that's this number right here. It's 44.6045.
How do you do the 31.8955? Yeah.
I took this number minus that number,
So you subtracted.
And then the other one was that.
add it. So this plus or minus means both, to add it first and then subtract it. Right? You subtract it to get the lower one, you add it to get the higher one. Okay, so here is my answer. I'm done with this. So on your test or something, you don't have to do this graph. This is not something I require. I'm just presenting it so that hopefully this makes a little bit more sense.
Are we gonna do one more
So we-
without all the extra stuff?
No, this is it. We got to move on to 9.3. Yeah, I'll go this way. Real quick.
So we're not finding like the actual values, we're just finding it with that sample, or for that sample.
Right, so we never really know what the real answer is, right? Because we're trying to estimate something we don't know. So that's my confidence interval. I hope it's in there somewhere. And remember, this confidence level means that if I asked 100 different people to go out and find their own sample and create their own interval, I'll have 100 different intervals. And if everybody followed this process and did everything correctly, I would expect about 95 out of 100 of those intervals to actually include the real answer. Unfortunately, I would expect about 5 of the intervals to just fail. They're not going to include it through no fault of their own. It's just that their result, these two, were so far away, like their sample values were so far away from the mean of the real distribution that even though they did everything correct, their interval just fails to include the real thing. Okay, so let me do this one last thing. So here is the interval from 31.89 to 44. And this is a t-distribution. This is my very best guess. But let's say the real answer, right? Let's say somebody out there knows the real answer. What if the real answer was actually a normal distribution that's like way out here, centered at mu equals to 57, with sigma equals to 3. Let's say that was the real answer. Well, obviously we're going to get an interval that's way off because our sample is way below the real one. Unfortunately, we'll never know when the real one is. Or maybe the real one is way over here. Maybe the real one is way over here. It's a mu of 17. And look at it, we got our sample was 38. That's crazy. That's really far away. So it doesn't include it. So we never really know where the real one is. All we can do is create our confidence interval and cross our fingers. Any questions?
Yes.
Yes.
So you don't actually have to know the standard deviation.
You don't actually have to know the standard
At the
deviation.
end. Like that's not a necessary piece of it. All you want is the confidence interval.
Well, we need that because this is this right here.
Yeah.
We need that times that.
Yeah. But you don't have to solve it out by itself and stick it
No.
down there.
As far as the work that is required, I mean, I want to identify. Well, this is given to you in the formula, so this is something I would consider. The work has been shown. You showed me the mean. You showed me what t-value you used. You showed me that the s value is this, and so therefore the whole standard deviation of the distribution is this. This is what I would consider showing your work. This graph thing is just something I did to help people see where that comes from. And then your final answer is just going to be this guy. A 95% confidence interval for mu comes from this. So that's all you really need.